Okay, now we move to part 5, which is a non-calculator section, and this is some more advanced integration techniques. And these types of questions are fair game for your gateway. So first one, we are going to do integration using completing the square. And what we want to do is use completing the square to put this guy in the manner that we can integrate with arcsine. And we kind of have to recognize that because we see the square root and we see a negative x squared under the square root. So that's sort of the pattern of arcsine, which would be the square root of 1 minus x squared. So I'm going to take what's underneath the radical out and rewrite it with a negative factored out here. Just, I think that makes it easier to complete the square. Frankly, with completing the square, you should always factor out the constant. So you have x squared plus 4x and then minus 21. What I added in here is this plus 4 minus 4. I knew I needed the plus 4 because I need this 4 divided by 2 and squared. The negative 21, it was negative because we had a positive 21 that we factored out the negative right here. So then I needed a plus 4, so I also need a minus 4. That way, this section here is the perfect square trinomial that factors into the square of a binomial, and then I have subtracted off negative 21 minus 4, so I've subtracted off 25. Then if I rewrite this by distributing the negative sign again, 25 minus x plus 2 quantity squared, and remember that was underneath the radical down here in the denominator. So I've rewritten my denominator. Actually, I'm not quite done. I need to factor out this 25. When I do that, I put a 1/5 over here out in front of the integral. And underneath, this 25 goes to 1, and then the x plus 2, I end up with x plus 2 all squared over 25, which I've rewritten as x plus 2 over 5 all squared. So at this point right here is when I recognize this as arcsine, and I know that I'm taking arcsine of x plus 2 over 5, which is right here. Then I have this 1/5 out in front, but then I also have to undo the chain rule, and the derivative of x plus 2 over 5 is 1/5. So when I undo the chain rule, I divide by the derivative of that inside function, and what happens, as you see, is that the 1/5s cancel out, and I'm left with just arcsine of x plus 2 over 5, and don't forget your all-important plus c. All right, the next one is also an arcsine problem, but one that does not require completing the square. This one is just when I factor out the 9 here. If I factor out the 9 from underneath the radical, I have this 1/3 out in front, and then the x plus 2 will be over 9, or excuse me, the x squared will be over 9, which is the same thing as x over 3 all squared. So this is how I've rewritten my integrand. And I recognize that I have arcsine of x over 3. And of course, when I integrate, I divide by the derivative of x over 3, which is 1/3. These cancel, and I'm left with just arcsine of x over 3 plus c.